For first point, in specific, what is water? Okay, water is a vital resource for life on Earth, and its efficient management of essential for the well-being of the planet and inhabitants. Climate change and the other factors, for example, urbanizations and aging infrastructure, are exacerbated and finished with the challenge faced with the water utilities. Uh, to address these issues, the water industry is turning to artificial intelligence to create smart water distribution systems that can optimize water use, reduce costs, reduce waste, and improve overall efficiencies. Okay, is a first part. What is the problematic? What is the principal issues? Uh, our studies shows that the principles problems or the principles issues that the problematic of the water distribution are inefficiency distribution for water through the network, water loss to the pipe leaks or uninterrupted uses, machinery breaking down, leaning and increased expenditures, inefficiencies, energy utilizations to inappropriate pumps schedules, and water contaminations to any points during the delivery process. That in the other, in additional informations, although is also interesting to mention, the use that the art problems is the operational level, as must also be mentions that the natural problems, for example, such as the lake or rainfalls, reductions of aquifers, amongst the other things. These reasons or these factors also aggravated the problem when we are having even on the global level. What is the motivations? What is the principal solutions? One of the primary applications of intelligence, artificial intelligence, is smart water distributions in the area of the lake detations. Water lakes are a significant problem for the water utilities, resulting of the loss of billions of gallons of the water each year. Uh, and this year, the water industry presents different problems with um, provide over to uh, different homes, different cases that mentions. Okay, the traditional methods of lake detections, such as visual inspection and listening devices, are labor intensive and often inaccurate. Uh, we we have job with different engineers, for example, with industrial engineers, civil engineers, and all all the team. We start with the studies, with the methodologies, methods, and different points, and different reasons, and different factors for attack the problematic of the water distributions. Okay, the the EI and graphs. By the pinpointing the location of leaks more accurately and quickly, utilities can reduce water loss, save money, save, save the aquifers, and minimize the environment impact of the wastewater. This problem is wrong for mondial level, for global level, etc. Dual graph. In order to create well-zone pinpoints, we use a dual graph where with help that Neo4j is great because we can refactor in graph model and creating specialized nodes. We use different methodologies for artificial intelligence. For example, linear regressions, neuronal networks, etc. Water distributions efficiency. Bemind to approximate, we can turn into a clusters base of neural networks that mentioned in a solution base of graph database. We applicate different topics and different methodologies um, for store or for processing the information in the database. For start for takes solutions that were distributions. And whereas AI, to begin, I can operate the designs on monitoring and the control networks as well as delivery facilities. After all approach, artificial intelligence can determine on content water loss or calculate the difference between the measurements obtains from the database and obtains an ML predictor to each control point. Is control points we can we can help to the demands of water and the other purpose. Um, our case of study. Um, Case of study we doing the Humapacor Tazar is industry is a water industry and a location specifically locations for Guanajuato Mech. My team and I um, job in these cities in these cities uh, and we attack the problem. We present the problem starts in January for this year. Um, and we study for different factors for attack the problem. Okay, what is the results? Our study we create 983 vertex and 118 edge with a mean of 4.5 and between 4.5 and 5.6 difference. This has 382 demand nodes with a total demands of 18.2 liters per second. We can show the result because in this show graph or using Euclidean distance, we use harmony distance of the minimum size h cross. Also, we study our nodes in order to achieve 18.2 layers per seconds. The demand nodes are distributed by the result predictor to spatial cover to entity supply area. And these times are modern water distribution efficiency or WTE are researched by 19% of entity supplies area. Okay, as additional information is worth mentioning that the application of the app with we my team use that that app makes useful for PLCs are the start processing the information. The PLC attack or the PLC obtain, we obtain the information for different reasons or for different topics. Will pass the information al database. The database in specific is SCADA. And begin processing this information for obtain the different networks, neuronal networks that we use to help the inhabitants for the city. The QR is for questions in specific, and that's all of my part.